So the first approach is being shown here. Here we are getting the head of the linked list as the input. So we will take a temporary variable for traversing the linked list. Why temporary variable? Normally we don't want to make any sort of changes in the main linked list, which is in our main function. Why? Because if the head somehow gets changed, then it will lead to an error. Although here it will not get changed, but still, in order to get back to the original head, we will require this head variable. So we are not going to do any sort of things with that particular head variable. Instead, we will take a temporary variable in order to traverse. We try to make that particular head always intact. We don't do any sort of mischievous things with that head. So we will do uh, this with the help of the temp variable. So we have the temp variable. We are initializing it with the head node. Now we will take a counter variable. I have named it x and initialized it with 0. Counter variable will help us to count the number of nodes in this particular linked list. So while temp is not equal to null, we will increment the counter to get the number of nodes in this linked list, and we will also move the temp pointer to the next node. So temp is equal to temp dot next, and we will keep on doing it until temp is not equal to null. So after we move out of this while loop, after this while loop gets completed, we will get the number of nodes in this linked list, and that will be represented by x. But what we will do is, in order to get to the mid node, we will divide this x by 2. So now x is equal to x by 2, and again we have initialized this temp node with head because we are again going to traverse from the very beginning. So let's see what we will do. Now since x is divided by 2, what we will do is, while x is greater than 0, we will take a loop, a while loop. While x is greater than 0, we are going to decrement this x minus minus, and until x is going to get minus minus every time. Okay, it will run the loop. So now we will do what inside the loop? We will again move the temp variable to the next node. So temp is equal to temp dot next, and as long as this loop will move forward, we are slowly getting ahead of the mid node which we are trying to return. So if there are 3 nodes, for example, then uh, the counter will be set to 3 initially. So 3 divided by 2 will be 2. Ones are 2. Okay, so 1 will be remaining in x. Now while x is greater than 0, that is 1 is greater than 0. Okay, 1 is greater than 0, then temp is equal to temp dot next. Okay, so it will move to the second node, and x minus minus, so x minus minus. So now here it is 1 minus minus, but here as we will get to the checking part, we will get 0. So 0 greater than 0, no, 0 is not greater than 0. So here we will terminate the loop, and now we are in the second node, and that is only the mid node because I said there were 3 nodes. So I will return that temp variable, and let's see, let's run this question. Mm, yeah, this is getting accepted. All the test cases are getting passed. So this was one method. Another method will be, let's reset the code to default code definition. Yep, confirm. Another thing will be to do it with the using the fast and slow pointer. We will take 2 pointers. This is a classical method actually. List node slow, initialize it with head, again another node. This will be fast. This is also initialized with head. Now while fast not equals to null, and fast dot next is also not equals to null. Slow is equal to slow dot next, and fast is equal to fast dot next dot next, and we will return the slow. Again, it is getting accepted. So yeah, all the test cases are getting passed and it is getting accepted.